fourth passage from the set, and this is the passage about farming. Let's take a look. As part of an international effort to address environmental problems resulting from agricultural overproduction, hundreds of thousands of acres of surplus farmland throughout Europe will be taken out of production in the coming years. Okay, so we have this issue of too much overproduction, and we're just going to take a bunch of land, hundreds of thousands of acres. That's a lot of land. We used to use it to grow corn. Now we're going to use it to do nothing. We're just going to take it out of production. Okay, so what I mean, this is give land time to heal itself, or what is it? Restoring a natural balance of flora to this land will be difficult, however. Why? Because nutrients in the soil that has been in constant agricultural use are depleted. Okay, that makes sense. You've been using this land. We've been using this land for decades to grow corn. We used up all the nutrients. So now even though we're not growing any corn on it anymore, it's hard for the natural balance of flora to reestablish because nutrients are depleted. And here's another problem. Okay, it's not the only issue. Okay, here's one issue. Here's another issue. It's also heavily fertilized. Why is that an issue? Why is that bad? I thought fertilizer was nutrients. Right? Why is it? Well, let's see. When such land is left unplanted, problem weeds like thistle often proliferate, preventing many native plants from establishing themselves. Okay. The heavy fertilization that we did to this land year after year after year, if you just leave it alone, what will happen is weeds will take over, like thistle will take over. And when weeds take over, well, the native plants won't establish themselves. And that's our goal, trying to get a natural balance of flora. So one is nutrients are depleted. Two is that the heavy use of fertilizers, it actually encourages weeds to take over, which are the thing, and they'll further crowd out the native plants that we actually want. Well, that's a problem. So this is definitely a problem. Well, what do we do? Maybe we have a solution? Well, here's the quickest way to restore heavily fertilized land is to remove and replace the topsoil. This is impractical on a large scale, such as that of European effort. Okay, well, nice try, but it's not going to work. They're saying, well, okay, you could do that. You could just scoop out the topsoil and then replace it. But we're talking about 100,000 acres, so yeah, that's not possible. All right, so what then? This is kind of just throwaway now. Well, another thing you could do is you could just wait, because it's generally believed that damaged ecological systems will restore themselves very gradually over time. You could just wait, but here's a study. Okay, here's a study underway in the Netherlands. It's investigating whether it's possible to artificially accelerate this process. Right, this process is referring to, the processes through which nature slowly reestablishes plant diversity. This idea of restoration, this idea of natural balance of flora. Right, so through which reestablish plant diversity on previous farmland. So here we're looking at possibly accelerating. Okay, so end of the first paragraph, we have a problem established. Overused farmland. We wanted to return to nature, so to speak, right? But it's difficult. And here we have a study in the Netherlands that's looking at how we might be able to help this process along faster. Okay, not bad. Let's keep going here. Second paragraph in the study. Oh, so we're going to learn more about the study. Great. Yeah, it's a natural link. Like every time there's a new paragraph, you want to be very sensitive to bridging the gap between the paragraphs, but here they made it easy for us just in the study. So, okay, fine. We're learning more about the study. The former cornfield was raked to get rid of corn stalks and weeds and then divided into 20 plots of roughly equal size. Fine. 20 plots is a lot. Control plots, I guess you have so much land, like we're taking so much out of it. But anyway, control plots were replanted with corn or sown with nothing at all. Yeah, so you want control plots because if you're trying to test some kind of intervention, you need to have control so that you can measure the difference. The difference between what your control and your intervention, that's attributed. The effects that are attributed to your intervention. So the control plots, we have two kinds of control. One is you just plant corn again, and the other is you just let it lie fallow. Okay, so that's the two kinds of control that we have. Now the remaining plots were divided into two groups. So we're trying out two different kinds of interventions. Okay, I mean, it's quite arbitrary. They could have divided into 10 groups if they want to try 10 different kinds of interventions. See which one of the 10 works best. But here they just want to try two groups, two interventions. Plots with one group were sown with a mixture of native grasses and herbs. So here's one intervention. You just sow native grasses and herbs on it. And the other group received the same mixture, but plus clover and toad flax. So one is just, the first group is just the mix group. That's the first intervention. The second group is the mix plus, I will call it C and T. CT for clover, toad flax. Now, if you observe any differences in the health, let's just say, of the two groups, of the two intervention groups, well, you can be sure that the differences is due to the clover and toad flax, because otherwise they're exactly the same. Right? So if you spot differences between the mixed group and the control group, say with nothing at all, well, you can be sure that the difference is owing to the intervention, the mix. Right? But if you further spot differences between mix and the CT, right, these two groups, well, then this is the difference. So it's because of clover and toad flax. Whether it's positive or negative, I mean, who knows? It could be good or it could be bad. Anyway, so that's the two intervention groups. Now, after 3 years, so we waited a while, thistle had been forced out of the plots where the broadest variety of species was sown. Oh, interesting, where the broadest variety of species have sown. So that's to say this group, right? Surely this group with the clover and toad flax is a broader mix than just the mix without the clover and toad flax. Okay, but so it's been forced out, but they've also disappeared from mats of grass and plots sown with fewer seed varieties. But on the control plots that were left untouched, that is to say lie fallow control plots, thistle have become dominant. Okay, so it worked. In fact, it worked for both of our interventions. That's great. So does that mean it's good, right? I mean, the study is promising. Now, in the third paragraph, one more paragraph, so let's keep going. On some of the plots sown with seeds of native plant species. Okay, so that's both of our intervention groups, right? Because both of them had a mix. Right, a mix of native. Soil from nearby land that had been taken out of production 20 years earlier was scattered to see what effect introducing nematodes, fungi, and other beneficial microorganisms associated with later stages of natural soil development might have on the processed native plant. Okay, as if it wasn't confusing enough already, we thought they only had 2 interventions. Actually, they had 4 interventions. They had they also had a 1.1. Mix plus soil. And they also had 2.1 mix CT plus soil. So it sounds like what they did was they took some of the mix and they split it into 2 more groups. One of them they just is nothing. You just leave it with a mix. You plant it with a mix of native grass and herbs. The other one you plant it with a mix of native grass and herbs, and then you also scatter some soil from the nearby land that's already been resting and recuperating for 20 years to see if the microorganisms in that soil that's been recuperating for 20 years, plus the nematodes, fungi, and whatever, see if it has any benefit. So, if you spot a difference between this plot and this plot, well, what does it due to? It's due to the soil. It's due to the microorganism, nematodes, and fungi. And then you did the same thing for the clover toad flax. I presume you did the same thing with it, because it just says here, on some of the plots sown with seeds of native plant species. Well, as a descriptor of this kind of plot, these kind of plots refer back to this one and this one, because both of these plots were sown with native plant species. So that's what the mixture is, right? So I'm presuming that's why I think it's like this. So yeah, let's see what happened. Well, the seeds sown on these enriched plots have fared better. There we go. Good. And then seeds sown on unenriched. So you guys did better. Maybe I'll put a plus sign over here to indicate that you guys did better than your counterparts, even though these counterparts did better than the control in the sense of pushing out thistle. But yeah, what do you mean fare better than the seeds? Still not as well as growing naturally. Oh, okay. But you know what else is even better still? Even better still is the 20 years, the land that's been lying fallow for 20 years. Researchers have concluded that, okay, so we're drawing a conclusion now. The researchers like, okay, I've seen enough. I'm going to make a conclusion. This is because fields farmed for many years are overrun with aggressive disease organisms, while, for example, beneficial mycorrhizas, are lacking. Oh, okay. So their conclusion, the researchers, after having run these tests and seeing the results, are concluding that, why? Like, why is it that these do better than these, but then these still don't do as well as the resting for 20 years? It's because of what's in the soil. It's because when you intensively farm land for too long, there's too much aggressive disease organisms and too little beneficial mycorrhiza. That's why if you take the soil from the good place and you scatter it over here, it actually does help. It does help. Okay, so these preliminary results suggest that restoring natural plant diversity to overfarm. Oh, so finally we get around to answering this question of, remember, like all the way in the beginning, we're wondering, from this study, is there a way to accelerate the process? Accelerate the process by which nature slowly reestablishes plant diversity on previously farmed land? It sounds like the answer is yes. This conclusion sounds like, we figured out why, which suggests something that we can do. So what is it that we can do? Well, it hinges on restoring a natural balance of microorganisms in the soil. Okay, that makes sense, right? You want to have the right fungi and nematodes and other microorganisms, mycorrhiza, whatever that is. In other words, diversity underground fosters diversity above ground. Okay, so it's what we can't see. It's what lies beneath the soil that's really the magic here. The researchers now believe that both kinds of diversity can be restored more quickly to damaged land if beneficial microorganisms are sown systematically into the soil along with a wide variety of native plant species. So you want to make sure you do this. Remember in the second paragraph, we talked about sowing the mixture of native grass and herbs. They're saying simultaneously sow it above ground with native grass and herbs and sow it below ground by taking the soil and just kind of scattering it, right? The soil thing. So you're sowing microorganisms below ground. So there's two kinds of sowing over here. So you notice I drew these breaks because this is the main conclusion. This is the suggestion. This is like the recommendation, the policy, the thing that we should do, the actionable, whatever you want to call it. This is the whole point of the passage. You get to the end of it, it's like, okay, now we know what we need to do. Great. We need to plant a mixture on top and we need to sow a mixture on bottom. Now, what's this over here? Well, these are the conclusions. Conclusions from the study, not to be confused with the conclusion of the whole passage. The researchers looked at all this stuff and it's like, okay, this is telling me, right? All this data is telling me that there are aggressive disease organisms in the soil and there's not enough beneficial organisms in the soil. That's my conclusion. From this conclusion, I draw this, I can formulate this actionable, this policy recommendation, this thing that we can do, right, which is ultimately the main conclusion of the whole passage. And now over here is just data. This is data, more description of the study and data. And over here is also more description of the study and data. But, the way this is the above ground stuff. This is the below ground stuff. This is the sowing mixture of native herbs and grasses. This is sowing a mixture of beneficial microorganisms. That's all mentioned in the main conclusion down here. Okay, and well, I guess that's it. So yeah, because it's just the first paragraph, which sets the whole thing up. Okay, let's take a look at the questions.